Pydantic AI's dependency injection mechanism utilizes the RunContext object to supply typed, runtime-evaluated data to dynamic, system prompt functions, ensuring strict type safety between the agent definition and its execution. By defining a custom data class and assigning it to the depstype parameter of the agent constructor, we will be establishing a type-safe contract that allows us to securely access network clients and credentials when passing the instantiated deps into the agentrun method to generate the final output. From data classes, import data class. Import httpx. From Pydantic AI import agent, RunContext. At data class. Class mydeps. API key, SDR. HTTP client, httpx, async client. Agent equals agent. OpenAI, GPT-5.2. Deps type equals mydeps. At agent system, prompt #1. Async def get system prompt dex. RunContext mydeps, SDR, #2. Response equals await CTX. Deps, HTTP client, get #3. https://example com. Headers equals authorization. fbearer CTX, deps, API key, #4. Response raise for status. Return fprompt, response text. Async def main. Async with httpx. Async client as client. Deps equals mydeps foobar, client. Result equals await agent. Run tell me a joke. Deps equals deps. Print result, output. Did you hear about the toothpaste scandal? They called it Colgate. This code demonstrates how to use dependency injection in Pydantic AI to construct dynamic system prompts at runtime. By defining a custom data class for dependencies, we establish a type-safe contract between the application state and the agent. The agent constructor receives the depstype parameter, which ensures that any function interacting with the agent context knows exactly what data is available. The core mechanism relies on the system prompt decorator and the RunContext object. When the agent executes, it passes the RunContext to the prompt function, granting access to the injected dependencies through the deps attribute. The function asynchronously uses the injected HTTP client and API key to fetch external data from https://example com, which is then formatted and returned as the system prompt before the language model generates its response. This pattern separates the static configuration of the agent from its runtime execution context. Injecting dependencies via the deps argument in agent.run makes the system highly testable, as you can easily swap out the HTTP client or the foobar API key for mocks during unit testing. It also ensures that the system prompt is always built using the most current application state, avoiding the need for global variables while maintaining strict type safety. Let's break it down. From data classes, import data class. Import httpx. Imports the data class decorator for defining structured data classes, alongside the httpx library for making HTTP requests. At data class, class mydeps. Defines a data class named mydeps to structure custom dependencies. The data class decorator automatically generates initialization methods for the class, creating a clean container that will be used to pass runtime dependencies into an agent. API key, SDR. HTTP client, httpx, async client. Declares two type-hinted attributes, establishing API key as a standard string and HTTP client as an asynchronous HTTP client from the httpx library. Agent equals agent. OpenAI, GPT-5.2. Instantiates a Pydantic AI agent and assigns it to the variable agent. configures the agent to use OpenAI's GPT-5 as its default language model.
At agent system prompt #1. Async def get system prompt dex. RunContext my deps SDR #2.
Registers an asynchronous function to generate a dynamic system prompt for the agent. The function accepts a runtime context object typed with custom dependencies, providing access to injected runtime data before returning the final prompt string.
Response equals awaits CTX. Deps HTTP client get #3. https://example.com.
Executes an asynchronous HTTP GET request to https://example.com using the client provided in the RunContext dependencies. The network call is awaited, and its result is assigned to the response variable.
Response raise for status.
Evaluates the HTTP response status code and raises an exception if it indicates a failure. This halts execution immediately upon encountering an error, preventing the program from silently processing an unsuccessful request.
Return fprompt response text.
Returns a formatted string that prefixes the text attribute of the response object with the literal word, prompt.
Async def main.
Defines an asynchronous main function that takes no arguments, typically serving as the primary entry point for concurrent execution.
Async with httpx. Async client as client. Deps equals my deps foobar client.
Establishes an asynchronous HTTP client context using the httpx library. Within this block, it instantiates a custom mydeps dependency object, injecting a string and the active client instance to prepare the runtime dependencies for an agent. Bridging static agent definitions with dynamic runtime execution requires a strict contract. Assigning the custom data class to the agent's dependency type locks in the exact shape of the required data. The RunContext then acts as the type-safe bridge between that static configuration and the live state passed into the run method. When the system prompt function executes, it securely pulls the active HTTP client and API key directly from this context to fetch external data before the language model ever sees the request. Because these network components are injected at runtime rather than hard-coded, the prompt generation process remains completely isolated from global variables. This guarantees the model always receives instructions built from the most current application state, while keeping the entire architecture highly testable and strictly typed from end to end.
The agent knows nothing, trusting RunContext to absorb a system prompt via httpx to become its mind.